Assalamu alaikum. This is the fourth class of transformation of functions of the P1 course. Today we are going to start with the stretches. Okay, the first stretch which we are going to learn is stretch parallel to the y-axis, or it is also known as the vertical stretch. How do you recognize the vertical stretch? In case of vertical stretch, there is a constant written before the function. Okay, so if it is 2 times f of x, or it can be a 1 upon 3 times f of x, constant is written before the function. Okay, it is a stretch parallel to the y axis. That means it's going to go vertically parallel to the y axis. The other stretch is the stretch parallel to the x axis. In this case, how do you recognize that? In that case, there is a constant being multiplied by x in the function. Wherever there is a x, a constant will be multiplied by x. Okay, this is called the stretch parallel to the x axis or the horizontal stretch. Okay, starting with the first question. Consider the graph of y equals to f of x alongside. On separate axes, draw the graph of y equals to 3 times f of x. 3 times f of x meaning it's a vertical stretch of stretch factor 3. That means every single the coordinate, the y coordinate will be multiplied by 3, and then you have to plot it. Now, if I do the first part on this graph. Okay, if it's a stretch parallel to the y axis, that means every point which has the y coordinate, for instance, if there is a gap of, there is a distance of 1 unit from the x axis, it will be the distance will be multiplied by 3. Every distance will be multiplied by 3. Okay, so whatever is the y coordinate, that will be multiplied by 3. The y coordinate here was a 1, it is multiplied by 3, and it has gone here. Now, here in this case, the y coordinate is a 0. It will be multiplied by 3. 0 times 3 is 0. That means this point will remain as it is, and these are invariant points which remain the same. In case of a stretch parallel to the y axis, or in other words the vertical stretch, the points which lie on the x axis remain as it is. So, this point will remain as it is, but this point is going to go will be multiplied by 3. So, if this is a 3 times f of x, if it is a negative 2, it will go on to negative 6. Negative 6 lies somewhere here. So, it is going to go here. Okay, so let me draw this. This will be the graph. If you notice, in case of vertical stretch, every y coordinate is being multiplied by 3. In this was a negative 2, it is multiplied by 3. Now, if I do the next one, if you notice, there is a constant being multiplied with x inside the bracket. That means it's a horizontal stretch, or a stretch parallel to the x axis. Now, if I draw this one here, every x coordinate will be multiplied by half. Now, the reason is that in this case the stretch factor is 3, but in case of a horizontal stretch, you reciprocate the constant here, and the stretch factor is going to be the reciprocation the reciprocal of this number, which is half in this case. That means every single x coordinate will be whatever is the coordinate of x coordinate, it will be multiplied by half, and then you have to plot it. Now, if you notice, this point is 4, half of it is 2, so it will be plotted here. Likewise, this point, it's going to be, it is a negative 4, so it will go on to negative 2. This point is negative 2, it will go on to negative 1. So, you have to just simply multiply every x coordinate by the stretch factor. In case of horizontal stretch, the stretch factor is the reciprocal of the function. Okay. Okay, as it is written here very clearly, the graph of y equals to f of a x is a stretch of the graph y equals to f of x with stretch factor 1 upon a. This number written here in the bracket is a. So, the stretch factor will be the reciprocal of this number. Okay. So, we just have to plot the graph now. So, the graph is going to be somewhat like this. Okay. Acha, another number, This is 2, so it will go on to 1. So I haven't plotted this, so I am just plotting it here. If you notice one thing in case of horizontal stretch, and that is any number which is any coordinate or any point which lies on the y-axis will be the invariant point, and it will remain as it is. Okay, because the x coordinates are being multiplied by 0, so here the x coordinate is 0, so 0 into 0 is 0, it will remain the same. Now we can summarize in short that in case of stretch parallel to the y-axis, the x-axis is the invariant line, is invariant. That means any point on the x-axis will remain the same, and in this case y-axis is invariant. Okay, starting with the next question, consider the graph of y equals to f of x alongside. On separate axis, draw the graph of y equals to 2 times f of x. 2 times f of x, if I just draw it on the same axis, both the graphs, okay, the one with this one we know this is a stretch parallel to the y axis, okay, or vertical stretch, and the stretch factor is 2. That means every point will be multiplied by 2, but any point which lies on the x-axis in this case, because it's a vertical stretch, the x-axis is invariant. So any point which lies on the x-axis will remain as it is. Okay, if I just give a stretch to this one, this is 2, so it will go on to 4. This will remain as it is. Any point on the x-axis will remain invariant. This is 3, it will go on to 6. This is 0, so it will remain as it is. This is 1, it will go on to 2. Okay, so if you join them, actually if I just mark one point here, this point is 1, so it will go on to 2. So I am marking this point so that the graph is easier for me to draw. This is the first part done. Now if you notice the second part, there is no number here, the number written here is a constant inside. So that means in this case I can say that it is a stretch parallel to the x-axis, stretch parallel to the x-axis, or I can say horizontal stretch, okay, with stretch factor. Now in this case the stretch factor is going to be the reciprocal of this number, so it will be 1/3. That means if you want to the y-axis is going to be the invariant line, this point will remain as it is. The rest of the points you have to multiply it by whatever is the distance, you have to take 1/3 of the distance. So if I take this, I have to go on to 1/3 of the distance. That means this point will go on to this. This point which is actually at 6 will go on to 1/3 of it, meaning 2, it will come here. Likewise, this point is going to go here, and this is 5. Okay, if you notice here, this is 5. 1/3 of 5 is 1 whole 2/3. So it will go here. Now I am just joining them and making the graph. This is going to be the graph. Okay, doing question number 2 right now. It says consider graph of y equals to h of x alongside. On separate axis, draw the graph of 1/3 of h of x. This is a stretch with stretch factor 1/3. Okay, and this is a vertical stretch. So I am just using vertical stretch, meaning it's parallel to the y-axis. Okay, so if I have to draw this, I will have to the x-axis is going to be the invariant line, so this point will remain as it is. This point will remain as it is. This will remain as it is. This is going to go 1/3 of the distance. That means here, 1/3 of it. Okay, 1/3 of it. And this, since this is 5, so it will go on to 1 whole 2 upon negative 1 whole 2 upon 3 here. Okay, so I'm just going to join them. If you notice, when you're joining the points, you will come across one very interesting thing, and that is any point which is lying on the y axis will remain the same. Okay, this is done. Now in the next part, we know it's a stretch parallel to the stretch with stretch factor 2, because the reciprocal of half is 2, and it's parallel to the x axis. Okay, so this is stretch with stretch factor 2, and it's a horizontal stretch parallel to the x axis. In this case, the y axis is going to be the invariant line. So if I just do it on the same graph, this point will remain as it is. Okay, any point which lies on the y axis will remain as it is. The rest of the points, you have to give a stretch of 2 units. That means this point will go 2 units. If it is if the gap is 3 units, it will go on to 6. Okay, likewise, if this gap is 1 unit, it will go on to 2 units, and this which is 2 units will go on to 4 units. Okay, so I'm just completing this side of the graph first. Okay, likewise, this point which is at a gap of 1 unit from the y axis will go on to 2 units from the y axis. Okay, so I'm completing the rest of it also. This is the final graph. 3 units, so the gap is now 6 units. It was 1 unit, the gap is now 2 units, and this was 2 units, so the gap is now 4 units. This is the final graph. Okay, moving on to this one. Write g of x in terms of f of x. F of x is the dotted graph and g of x is the red graph. If you notice, every point has gone double the distance from the x axis. This was 1 unit, now it has gone up to 2 units. This was 3 units, it has gone up to 6 units. That means this is a stretch, vertical stretch with stretch factor 2. So you can write g of x equals to 2 times f of x, because vertical stretch you write it, you write the constant here, which is actually the stretch factor. Since every point is double the distance now, so the stretch factor is 2. In this case, if you notice, this is the original graph, which is y equals to f of x, and this is g of x. If you notice that every point from the y axis has gone 3 units, thrice the distance. It was 1 unit here, it has gone on to thrice the distance. Likewise, and if you notice, y axis is the invariant point. Okay, if y axis is the invariant point, that means it's a stretch parallel to the x axis. So the stretch factor is 3. Okay, how do we write down the stretch factor in this case? We will write g of x equals to f of 1 upon 3 x, because the stretch factor is 3, so you will have to write 1 upon 3 of x here. Okay, going on to this question, the diagram shows the graph of y equals to f of x. Sketch the graph of each of the following functions: 3 times f of x and f of 2x. Okay, so firstly I am drawing the graph here. For the A part, and this is for the B part, and this is the original graph here. Okay, since this is a vertical stretch, stretch factor is 3. Okay, so x axis will be the invariant point, this will remain as it is, point on the x axis will remain as it is. Every single distance will be thrice the difference, thrice the distance. 1 unit distance, so it will go on to 3 units. 2 units, it will go on to 6. This point will remain as it is. This distance is 2, it will go on to 6, and this is 1, so it is going to go on to 3. Okay, let me just quickly join the lines. You notice when you're drawing it, the point which is lying on the x-axis will remain as it is, because x-axis is invariant in this case. This is the graph. Okay. Now, if I have to do the second part, this is the stretch parallel to the x-axis and it's a horizontal stretch with stretch factor half. So, I am writing horizontal stretch and stretch factor is half. Whatever is the number written here, you reciprocate it and that becomes a stretch factor. Now, in this case the y-axis is the invariant line. So, this point will remain as it is, this point will remain as it is because it is lying on the y-axis. The rest of the points you just have to do what? You have to, whatever is the distance from the y-axis, you have to make it half. So, this point which is at a gap of 2 units from the y-axis will go on to 1, 3. If you notice, there is a gap of 3 units. So, you make it into 1.5, half of it. Okay. And this point which is at a gap of 6 will go into 3. On this side also it will go into half, 1.5, and 6 will go on to 3. This is the graph, final graph. I am just drawing it here. This is the final graph. If you notice, y-axis is invariant in case of horizontal stretch. Every point you just have to see what is the distance from the y-axis, just make it into half and plot the point and then finally join the graph. Okay. Find the equation of the resulting graph when the first part x square plus 2 is vertically stretched with stretch factor 2. In this case, in the first part, you know that the stretch factor is 2 and it's a vertical stretch. So, simply you have to multiply the graph by 2 times f of x. So, it's going to be 2 times x square plus 2. The resulting answer is going to be 2x square plus 4. This is the answer for the first part. The second part, y equals to 5 minus f of x equals to 5 minus 3x is horizontally stretched with stretch factor 3. Horizontal stretch meaning stretch factor is 3, so it's going to be 1 upon 3x. That means in place of x in the function, you just have to plot 1 upon 3. So, the resulting answer is going to be 5 minus x for this part. Okay. Moving on to the third one, the C part. It says f of x equals to this is vertically dilated with stretch factor 1 upon 4. Vertical dilation of scale factor 1 upon 4, meaning you have to multiply f of x by 1 upon 4. Okay. So, it is going to be 1 upon 4 times the equation, which is x cube plus 8x square minus 2. When you multiply all the terms by 1 upon 4, it will become 1 upon 4 x cube plus 2x square minus 1 upon 2. Okay. The last part now, which says horizontal dilation with scale factor half. So, you will have to write it like this: f of 2 scale factor is half. So, you have to write 2x in this. That means in the function wherever you have x, you have to write 2x. This will become 2 into 4x square plus 2x minus 3. This will become 8x square plus 2x minus 3. This is the final answer. Okay. Moving on to the next question, question number 2. It says find the equation of each graph after the given transformation. Okay, y equals to 3x square after stretch parallel to the y-axis with stretch factor 2. That means you have to give it a vertical stretch. So, it is going to be simply, you just have to multiply it by 2, the equation. So, this will become 6x square. This is the equation, y equals to 6x square. This is the answer to the first part of the question. The B part, it says y equals to x cube minus 1 after a stretch parallel to the y-axis with stretch factor 3. Parallel to the y-axis meaning the vertical stretch and stretch factor is 3. Simply you have to multiply the equation by 3. So, the answer is going to be 3x cube minus 3. Okay. The C part, It says stretch parallel to the y-axis with stretch factor half. Simply you have to multiply the equation by half. Okay, half can be written as 2 to the power negative 1 into 2 to the power. Okay, first of all I am not writing it this way, I am multiplying it the normal way. Half into 4 is a 2. Now I can write half as 2 to the power negative 1 into 2 to the power x plus 2. So this can be written as 2 to the power x minus 1 plus 2. This is the final answer. Okay, the D part. It says y equals to this after stretch parallel to the x-axis with stretch factor 2. Stretch parallel to the x-axis meaning the horizontal stretch, and stretch factor is 2. So in place of every x you have to plug in 1 upon 2 of x. Okay, so I am writing down the equation first of all. Since the stretch factor is 2, so you have to plug in 1 upon 2 times x in place of every x. When you simplify, you get 1 upon 4 x square minus 4x plus 10. This will become 2 1 times 2 2 times. So half x square minus 4x plus 10. Okay, the last part now, which is the E part. It says stretch parallel to the x-axis meaning the horizontal stretch with stretch factor 1 upon 3. If stretch factor is 1 upon 3, that means in place of every x you have to plug in 3x. Okay, so E part, the equation I am writing it as it is as a first step. In place of every x I have to write 3x. This will become 6 times 27x cube minus 108 times x. 27 6 times is 162 x cube minus 108x. This is the final answer. So this question is also done. Moving on to the next one. Question number 3. Describe the single transformation that maps the graph this. Now in this case you have to describe. So if you just observe the graphs. Okay, this is the main equation and you have to describe the transformation which maps this graph onto this graph. Now if you observe that in place of x, if I substitute 2x, in place of every x if I substitute 2x, I will get this resulting graph. Okay, so the A part, what I am going to do is y equals to x square plus 2x minus 5 is the equation. If I plug in x as 2x and solve it, I will get the resulting graph which is 4x square plus 4x minus 5. That means it's a stretch. Whenever you have to plot in place of x a constant being multiplied by x, that means a stretch. It's a horizontal stretch with stretch factor, whatever the number you've written here, reciprocal of this. Stretch parallel to the x-axis or horizontal stretch. With stretch factor 1 upon 2. Okay, in the B part, the equation is y equals to x square minus 3x plus 2. If you notice, what they have done is they have multiplied the whole equation by 3. So I can just multiply it like this, 3 times x square minus 3x plus 2. I am going to get 3x square minus 9x plus 6, which is exactly what they have given us. That means the whole function is being multiplied by 3. So whenever the whole function is multiplied by the constant, that means it's a stretch parallel to the y-axis, or it's a vertical stretch with stretch factor 3. Okay, the C part, if you notice, they have multiplied the whole of this equation by 2. So when you multiply this by 2, so x plus 1 will come here and 2, that means the whole equation is multiplied by 2. So in the C part, I can show it to you, 2 to the power x plus 1, when you multiply it by 2, this will become 2 to the power x plus 1 plus 2. So you will say it's a stretch, it's a vertical stretch or parallel to the y-axis You can even call this as stretch with x-axis invariant. Whenever it's a parallel to y-axis, the x-axis is the invariant line, so you can even call it as stretch parallel to y-axis or stretch with x-axis invariant, or vertical stretch, and stretch factor is 2. Okay, the last part, the D part, I am just copying the equation. It's y equals to root x minus 6. Now that means the whole of this equation, in place of x they have plugged in 3x in place of x. So if I just do it here, y equals to, in place of x they have plugged in this to get the resulting equation. So that means it's a stretch parallel to the x-axis with stretch factor 1 upon 3. Okay. Okay. This is another question here. It says, suppose f and g are functions such that g of x equals to 3 times f of 2x. What transformations are needed to map y equals to fx onto y equals to g of x? F of x onto g of x. If you are noticing that it is given the vertical stretch of 3 and a horizontal stretch of 1 upon 2. So you can write it, a vertical stretch, if you want you can write it parallel to the y-axis with stretch factor 3 and followed by a horizontal stretch with stretch factor 1 upon 2. Or you can write a horizontal stretch followed by the vertical stretch. A horizontal stretch of stretch factor equals to 1 upon 2 followed by a vertical stretch of stretch factor 3. Either you do the vertical stretch first or the horizontal stretch, eventually the final graph will be g of x. Okay. The next question is graph on the same axis. Graph on the same axis, on the same set of axes, y equals to x square, y equals to 3x square and y equals to this. Describe the combination of transformation which maps x square to 3x plus 1 the whole square minus 2. So, I am doing the first part first. Okay. I am not drawing it, okay, but I am just describing the transformation. Now, if you notice, this is given a vertical stretch of 3 followed by a translation. Okay, there is a positive 1 here, that means the translation vector is going to be negative 1, negative 2. So, I can write that in the A part, it is a vertical translation, vertical stretch of 3 units. Because why a vertical stretch? Because 3 is written before the graph, the equation of the graph. Okay, it's not written in place of x. So it is a vertical stretch parallel to the y-axis. If you want, you can add with x-axis invariant, followed by a translation. If you don't understand why is it a translation, I can brief you on this and you can go through the first and the second class of graph of functions, the transformation of functions of the P1 course. If you notice in this equation, 3 is outside the bracket, there's no number being multiplied by x. If a number is being multiplied by x, that means it's a horizontal stretch with the stretch factor reciprocal of the number which is being multiplied by x. There's a positive 1 here, that means it's a translation going on. Positive 1 meaning if you make this bracket equals to 0, you get a negative 1. That means the movement on the x-axis is negative 1 and the movement on the y-axis, the whole graph is going to go 2 units down then. That means a translation of with a translation vector of -1, -2. With translation vector -1, -2. Okay. I can explain it to you this way. If this is the graph of x square cube, the graph of 3x cube will be like this, and then obviously because of this translation the whole graph will go 1 unit onto the left and 2 units down. So I am just drawing a rough thing, 1 unit onto the left and 2 units down. That means the whole graph is going to be like this then. This is the final graph. Okay, I am doing the next part here. Graph on the same set of axes. Graph on the same set of axes, y equals to x square, y equals to half x square, and then y equals to half x plus 1 the whole square plus 3. So since in place of x they haven't plugged in anything, they've just multiplied the whole function by half. That means a vertical stretch with stretch factor half. So it's a vertical stretch with stretch factor equals to half, followed by a translation. Because see, if you deal with this, in the bracket in place of x they have added something, addition or subtraction meaning a translation, not a horizontal stretch. In case of horizontal stretch it will be 2x or 3x or 1 upon 3x. Okay, but if it is being multiplied by x, and constant is being multiplied by x, but since there is an addition or subtraction going on, that means a translation. Make this equals to 0 and you get x equals to -1 and the y coordinate as it is with translation vector -1 and 3. I can draw the graph for you, just a rough sketch. The original graph is y equals to x square, which I am drawing it here. This is the original graph, y equals to x square. Okay, now I am going to draw the graph of y equals to half x square. That means every distance will be half. So that means it's going to be somewhat like this. The graph is going to be like this. Okay, this is the graph of y equals to half x square. Now this whole graph is to be translated by the vector -1 comma 3. That means -1 meaning 1 unit onto the right, onto the left, and 3 units up. So I am going to draw the final graph with black, 1 unit onto the left and 3 units up. The final graph is going to be this one. This graph is actually translated to this. So this is going to be your final graph. Okay, moving on to the last question which you have here. In this case, I'm not going to draw the graph. I'm going to directly describe the transformation which is taking place, a combination of transformation which is taking place. Y equals to x square and then 2x square, that means a vertical stretch of 2 with stretch factor 2 and then a translation. So I'm writing vertical stretch of with stretch factor 2 and followed by a translation of 3 2 and 1. Okay, the next one, okay, this is also the same. Vertical stretch of stretch factor with stretch factor 2, followed by a translation of -1, -3. Okay, this brings us to the end of this. Uh, uh, Now we're going to do questions from the past papers and some questions where the transformations are combined. Thanks a lot for watching the video.